In this lecture, I will talk about mechanism of heat transfer. So far we have discussed this transfer of energy as heat between a system and its environment. Here we describe how that transfer takes place. There are three transfer mechanisms: conduction, convection, and radiation. So there are three transfer mechanisms. First is conduction, convection, and radiation. So we will talk of these three mechanisms a little bit in detail in this lecture. So let's talk first about conduction, right? Um, so if I have a slab of thickness, let's say L, and temperature on one side of the slab is, let's say, higher temperature TH, the other side is lower temperature or cooler temperature TC. So the rate at which heat energy is transferred or is conducted through this slab is given as, so let's say P conduction, we are talking of conduction, is the rate at which heat is conducted or transferred. So this will be given as K A TH minus TC over L. Okay, so P conduction is given by this expression here. Okay, K is called thermal conductivity. A is the cross-sectional area of the slab, and L is the thickness. Okay, and if I look if we look at this relationship, P conduction is the area. So this is the area, right? So this is the area or cross-sectional area, right? This is the cross-section area. So bigger is the area, faster is the rate of transfer. So it's proportional to A. Same thing, TH minus TC, that's a temperature difference between the hot side and cold side. So again, higher, from our experience we know, the higher is the temperature difference, faster the transfer of the heat, right? And L, again, is the thicker is the L, thicker is this separation between TH and TC, slower is the rate, right? So we can insert here just for future, because this is we can leave it here, and we can say this is the rate of which heat is transferred. So we can say this is Q and this is my time. Q over time is the rate of energy transfer. Couple of units. K is thermal conductivity, so unit is going to be let's say P. What's the unit of P? P is joule, is energy over size, so watt, right? So watt, and then this is meters, so this is per meter, and then per Kelvin. All right, and of course the unit of P, or heat transfer rate, is joule per second. Right. We may have a scenario where I have this side, let's say TH, same, but instead of having just one type of slab, I may have several slabs of just several thicknesses. So I can have, let's say I take an example here. Let's say I have two slabs. One is thickness L1. Let's call it L1. And this is my K, conductivity K1 of this material. And then I have thickness L2, and this is K2. And this side is temperature is colder temperature TC. So in this case, the P conductivity is given as A TH minus TC divided by L1 over K1 plus L2 over K2. Or if we have several layers like that, so we can say A TH minus TC over summation of L, let's put it I over Ki, and summed over I. This L over K has a name, and this is called, and we can say this is called R, and this is called thermal resistance. Or sometimes we call R value. All right, so this equation, again, this equation useful when we have a situation something like this of different layers of thickness of different conductivities. All right, so maybe let's say just mark this as my another useful formula. We'll talk in the class. We'll solve some problems on this one. Great.